Hi there and welcome to Hegarty Maths. It's Mr. Arnold here and this is the fifth video on differentiation. We're going to focus on some maximisation and minimisation problems, and it is based towards the core maths modules for A level, but is applicable to lots of other maths modules also. Alright, so we're just going to do two fairly big examples here on applications of differentiation. So let's have a look at the first one. The diagram shows a baking tin in the shape of an open-topped cuboid made from a thin metal sheet. The base of the tin measures x by 2x centimeters. The height of the tin is h centimeters, and the volume of the tin is 4,000 cubic centimeters. Part A is to find an expression for h in terms of x. So, the information that we're given in the question is the volume of the tin is 4,000 centimeters, and the volume equals 4,000 centimeters cubed, and also it's a cuboid, so to get the volume of a cuboid you do the length by the width by the height, so h times x times 2x. So volume equals h times x times 2x. And let's just tidy that up. We get h 2h times x squared. Now the volume is 4,000, so I'm going to replace v with 4,000. So 4,000 equals 2h x squared. Remember, we want an expression for h, so in other words we've got to make h the subject of this formula. So we're going to divide both sides by 2, and finally I'm going to divide both sides by x squared. So we get h equals 2,000 over x squared. So now we have an expression for h. Part B is to show that the area of the metal sheet used to make the tin A is given by this equation here. A equals 2x squared plus 12,000 over x. Okay. Well, the area of the surface area of this cuboid is going to be h times x here. And then the far side you also have h times x. This face here is going to be 2x times h, 2xh, and then the far side will also be 2xh, and the base of the tin is going to be x times 2x, which is 2x squared. So the area will be given by, well, we've got 2hx here, we've got 2xh and 2xh here, which is 4xh. In fact, I'm just going to modify this a little bit because 2xh and 2hx are the same thing, hx, and then we've got the base, which is 2x squared, and tidying this up we end up with 6 hx plus 2x squared. So a equals 6hx plus 2x squared. Six hx plus 2x squared. Well, we know that h equals 2,000 over x squared. So let's replace the h with this expression here. So we get 6 times 2,000 over x squared times x plus 2x squared. Well, 6 times 2,000 is going to give me 12,000, and x squared is underneath. If I times that by x, I'm going to end up with x underneath the line as the denominator, plus 2x squared. I think that's what we were looking for. 2x squared plus 12,000 over x. So absolutely 2x squared, let's rewrite it the way it said in the question, 2x squared plus 12,000 over x. Lovely. Okay, next part is to use differentiation to find the value of x for which a is a minimum. So what we need to do is differentiate this function here. So I'm going to get dA dx, differentiate the area with respect to x, and we get 2 times 2 is 4, reduce that power by 1, plus, now I'm going to rewrite this just to make life a little bit easier. In green, this is actually 2x squared plus 12,000 by x to the power of minus 1, just so that when we differentiate it becomes clear what's going on. So take the power down in front, negative 1 times 12,000 is negative 12,000, and reduce the power by 1, x to the negative 2. So maximization and minimization are stationary points. So from the last video, we're going to have a max or a min when dA dx is equal to 0. So 4x minus 12,000 x to the negative 2 must be equal to 0. Okay, I don't like that x to the negative 2. I'm going to multiply everything by x squared. So we get 4x cubed minus 12,000 equals 0. Okay, so let's add 12,000 to both sides. Now what we're going to do is divide both sides by 4. And then we're going to take the cube root. So x will equal the cube root of 3,000. Alright. Remember, this comes up in the core 2 paper, so we can use a calculator. We're going to take shift and we're taking the, that hasn't worked. Let's try that again. So we're taking the cube root of 3,000. And we're going to give our answer to 3 significant figures, so it's going to be 14.4. So x equals 14.4, and that's to 3 significant figures. Okay, so that's the value of x for which we have a minimum. Now we're asked to find that minimum value of a. So what I'm going to do is substitute my point. So this is part D now. I'm going to sub x equal to 14.4 into the formula for a. So reminding ourselves, 2x squared plus 12,000 over x. over x. So a equals this, substituting it in, 2 times 14.4 squared plus 1200 over 14.4. Let's take out the calculator, let that do all the hard work. 2 times 14.4 squared plus 12,000 over 14.4. Let's go to three significant figures again. So to three significant figures, we get 1,250. So this is approximately 1,250 centimeters squared. Okay, and then the final part is to show that your value of A is a minimum. So to prove that it's a minimum, I've got to take the second derivative. So we're going to want to take d squared A dx squared. So the second derivative is going to equal 4 plus, and then 24,000. 4 plus 24,000 x to the negative 3. And now what we're going to do is we're going to evaluate d squared A dx squared, evaluate that when x equals 14.4. Let's take our calculator out. So taking the calculator out, we get 4 plus 24000 times, well, x is 14.4 to the power of negative 3, and we get 12.04, and as 12.04, remember it's greater than 0, that implies point is a min. Point is a minimum. Or the value is a minimum, should I say. Okay, let's have a look at the second example now. So we got another diagram here. Closed plastic cylinder used for making compost. The radius of the base and the height of the cylinder are R and H respectively, and the surface area is 30,000 centimeters. Show that the volume of the cylinder is given by V equals 15,000 R minus pi R cubed. Okay, well, we've got information and it's about the surface area. Let's think about the surface area of a cylinder. It's closed as well, so we're going to have the area of this circle at the bottom, the area of this circle at the bottom, and also the area of the curved surface area, if you will. So, the surface area, in fact, let's come down a little bit. The surface area equals 30,000. Now I'm going to want to write down the surface area in terms of R and H. So we're going to have pi R squared and pi R squared. So we've got 2 pi R squared. 2 pi R squared, because we've got 2 circles. And then the curved surface area is the circumference of a circle, circumference of this circle times by the height. Circumference of a circle is 2 pi R, and we need to times that by H. So 2 pi R times H gives me the curved surface area, and that's going to equal 30,000. Okay, let's see what we can do here. We're also told that the volume, well, what is the volume of a cylinder? It's going to be the area of the base multiplied by its height. So pi R squared pi r squared times by h. Now what we're going to need to do is we're going to need to work out what h is, because our formula doesn't have any h in it. So I'm going to manipulate this equation here and get it in terms of h. Okay, so first thing I'm going to do is take 2 pi r squared away from both sides. So we get 2 pi. In fact, I'm going to make life a little bit easier for myself. I'm going to factor out 2 pi r. Let's factor out 2 pi r. 2 pi r. And that leaves me with r plus h. And that equals 30,000. Divide both sides by 2 pi r. And we get r plus h equals 30,000 over 2 pi r. In fact, I can cancel the 2 into the 30,000 and get 15,000 over pi r. And then lastly, I'm going to take r away from both sides. So h equals 15,000 over pi r, subtract r. Okay, now we have an expression for h. So we know what h is. We're going to put it into this formula here. So v equals pi r squared h. So v equals pi r squared h. But we now know what h is, so v equals pi r squared times 15,000 over pi r minus r. Brackets is in the wrong place there, sorry. So, like so, okay. So let's see what happens if I multiply pi r squared in here. So expanding the bracket, if you will, I'm going to get 15,000 pi r squared, and that's still over pi r, minus pi r cubed. Hopefully you can see that the pi cancels with pi and r goes into r squared, leaving us with 15,000 r minus pi r cubed. What were we looking for? Perfect, 15,000 r minus pi r cubed. Okay, excellent. Next part is to find the maximum volume of the cylinder and show that it's a maximum. So, to show the maximum, the max occurs when dr, so the derivative of v with respect to r is equal to 0. So let's get dv dr. So differentiating this, we get 15,000 minus 3 pi r squared. So we're going to let this equal 0 minus 3 pi r squared equal 0, which implies, okay, first thing I'm going to do is I'm going to add 3 pi r squared to both sides. So we get 3 pi r squared is going to equal 15,000. Divide both sides by 3. equals 5,000. In fact, let's divide by pi as well, and take the square root. So r is actually going to equal 5,000 over pi and take the square root. So let's take out the calculator. So we're taking the square root of 5,000 over pi. Where's the pi button? It's down here. Let's go to 3 significant figures. It's going to be 39.9. And let's do 3 significant figures. Okay, so that's the value of r. So now we need to find this maximum volume. So I'm going to substitute this value of r in. So we're going to sub it into. Yeah. Okay, so let's substitute the value 39.9 into the formula for volume. Let's take a copy of this. Bring it down. So V will equal 15,000 times 39.9 minus pi times 39.9 cubed. So out with the calculator. $15,000 times 39.9 minus pi times 39.9 cubed. And let's do this to 3 significant figures. So to 3 sig fig, it's going to be 399,000. Okay, 399,000 cubic centimeters. That's the max volume. Now the last part is we need to show that the value is a maximum. So what we need to do is get the second derivative. So take the second derivative. D squared V dr squared, and that's going to be negative 6 pi r. Negative 6 pi r. And negative 6 pi r, regardless of what value we put in, negative 6 pi r must be less than 0, which implies the value is a maximum. Okay, that's it for this video. Hopefully you found it useful. Back again with another video soon. All the best and take it easy.